Hi, in this video we will continue studying chain rule. We'll do more examples and we will learn new things. In particular, we will derive a rule which is called general power rule. It's a combination of chain rule and power rule, but having it in this new form will be much more useful for us in this course. Okay, so let me recall what we had. We had the chain rule was, well, when you have combination of two functions, the derivative is given by the derivative of the inner one times the derivative of outer one evaluated at inner one. Well, sometimes to make everything look better, what we do, we choose to write this inner function as u. So the chain rule turns in this form. So derivative of f at u differentiating with respect to x. This is going to be, well, g prime, which is u prime, times f prime at u. So this is the same rule, but we are writing in a little bit different form. Why it is nice writing this way? Because, well, sometimes makes more sense seeing functions as function of another variable. Well, it will make life a little bit easier for us. So for example, let's just do some examples. Find the derivative. Find the derivative while using this u thing. So first one is function is root x cubed plus 2x plus 4. And then the second one is 1 over 5x plus 4. So here, what we see is that, okay, this guy is first we compute this x cubed plus 2x plus 4 and then find the derivative of this. So if you see u as this guy, then the function we are working with is nothing but square root of u. Yeah, so then we can find the derivative of that function, seeing it as root u. Well, by doing what? This is going to be u prime derivative of root, which is 1 over 2 root u, you multiply it. So this is exactly this. You have to do the differentiation, the regular differentiation rule. In this case, root u, the derivative is 1 over 2 root u. But then you multiply it by u prime. So that will give us u prime here is, u prime, which is derivative of x cubed plus 2x plus 4 prime over 2 root x cubed plus 2x plus 4. We are not done yet. We have to differentiate the numerator. This is polynomial, so it will be 3x squared, the derivative of first one, plus 2 and then plus 0. So I don't write that piece. This is x cubed plus 2x plus 4. How about this other one? Well, we can see this as 1 over u. U here is 5x plus 4. then the derivative of this guy is u prime, so 5x plus 4 prime, times derivative of 1 over x, well, 1 over u. This, we know that derivative of 1 over x is just negative 1 over x squared. So here what we have is times negative 1 over u squared. Well, here u, we know what is u. U is 5x plus 4 to the power 2. And as you can see, this will give us minus 5x plus 4 prime over 5x plus 4 squared. And in the numerator, you see the derivative of 5x is 5 and derivative of 4 is 0. So we get negative 5 over 5x plus 4 squared. Well, in particular, what we see here, so this is a remark that if f is the function which puts the derivative to the power n, then derivative of fu, it means that there is a variable, a third variable, f of u, and we are differentiating with respect to that. In other words, what we have f of u is u to the power n. So let me write this thing. This is the derivative of u to the power n is equal to what? Well, first, derivative of this guy is going to be f prime of x is going to be n x to the power n minus 1. That's almost there. So n u to the power n minus 1. And then you multiply this whole thing by u prime. This is, we are applying the chain rule, u prime times f prime at u. So this says that, well, the rule is n times u prime u to the power minus 1. And let me write this, and your book likes to say this is general, the general power rule. You will see me or hear me saying power plus chain. That's what I like to call them. Okay, so what is this? This is, if you're trying to find derivative of u to the power n, this is very similar to what we had before, n u to the power n minus 1, but you have to multiply the derivative of u there to have the complete and correct derivative. That's what we have. I have some examples here for you. Let me bring them. Okay, nice. Okay, so we will use this power rule. So if you're looking for derivative of these guys, basically this is x squared plus minus 2x cubed. The derivative is, well, use this rule. This is something called this one u. So now this is n first. 3 comes up front. U prime, so derivative of whatever you put as the base of the power, times u itself to the power 1 less. Now I can find the derivative of this piece. Derivative of this is polynomial, so this is 3 times 2x minus 2 times x squared minus 2x to the power 2. It's very similar to what we have, nu to the power n minus 1, but now we have to multiply this extra factor, the derivative of the function inside the power. Okay, for this other one, the derivative of, well, the third root of 4x minus 5 is the same thing as 4x minus 5 to the power 1/3, yes? And that gives us what? N comes up front, this is n, times derivative of the function 4x minus 5 times 4x minus 5 to the power 1 less power. Then this gives us, well, derivative of 4x minus 5 is 4x minus 0, which is just, sorry, it's 4 minus 0, which gives me 4 over 3, 4x minus 5 to the power negative 2 over 3. How about this one, dx of, well, first this thing, I can see it as x minus 3x squared to the power negative 5. And while n comes up front, that's n, then you have to multiply this by the derivative of the function. Then the function to the power 1 less. Here we have negative 5 times derivative of this is 1 minus 6x. And then this gives us x minus 3x squared to the power negative 6. But this is the same thing as negative 5, 1 minus 6x. Let me do this thing here, a bit space I get there, over 6 minus 3x squared to the power 6 in the denominator. And well, for the last one, this is also very nice here. So I'm trying to find the derivative of 1 over x to the power 10 minus 5x. I can see this as x to the power 10 minus 5x to the power negative 1. And that is, n comes up front. This is n. Then derivative of this, x to the power 10 minus 5x prime times x to the power 10 minus 5x to the power 1 less than the original. This now is negative derivative of x to the power 10 is 10x to the power 9 minus 5 times, this is x to the power 10 minus 5x to the power negative 2. I can put it in the denominator and write it as x to the power 10 minus 5x to the power 2. And yeah, that's basically general power rule or chain plus power rule. That's what we have. Okay. Here we have another example. This time this is a function is given, differentiable function, and that is differentiable. And there's a table of values here. We want to find the derivative of these functions you see here at given points. So the first one, starting with the first one, we are trying to find the derivative of f of x to the power 2. That's h prime x, yes. Well, first thing first, this is basically a function u to the power 2. 2 comes up front. Then we find the derivative of that function. Then that function to the power 1 less. So this will give us 2 f prime x f of x. So this is the derivative of h at x. So now h prime at 1 is when you plug in 1 into the function. And f prime at 1 is 5. So 2 times 5 times f at 1 is 0. So this gives us 0 value. How about this other example here? So this time h prime of x is, we are trying to find derivative of x when it is f of x to the power -1. A function to the power a number. This is the general power rule. N comes up front. Then the derivative of the function, then f of x 1 less than that. This gives us minus f prime of x times f to the power -2x. Well, you can rewrite this. Let me write this. F prime of x over f of x squared. Then h prime at 2 is going to be negative f prime at 2 over f of 2 squared. This is f prime at 2 is -3. This is, I see it from the table, over f at 2 is 2 here, and then square it. This is 3 over 4. And as the last example, h prime at x is the derivative of this function, which is the same thing as this guy. Then this comes up front. Find the derivative of this function, and then 1 less than the function. This is 1/5 of f prime of x, f of x to the power -4 over 5. Well, then let's just evaluate this value. H prime at 3 then is going to be, well, again, let's try to write this thing another time. Minus f prime of x is going to be in the numerator, 5 is in the denominator, and this guy is f of x to the power 4 and the 5th root of that. Well, in this case, f prime at 3 is, oh, let me write it first. F prime at 3 over 5, 5th root of f at 3 to the power 4 minus f prime at 3 is -4. Oh no, f prime at 3 is -2, and f at 3, this is the value I'm using, is -4. So it's -4 to the power 4, and this is a big number. Well, strange number. I don't need to compute that. I just leave it like the 1/4, the 5th root. This was, as I said, just some kind of, you can say, application or some kind of implication of chain rule when we apply it on the power rule. So it's called general power rule, as it says.